Now, without further ado, let's proceed to our first lecture today by Bat-Ulzii Luvsanbat, developer from Microsoft, engaged in C++ compiler front-end team. He's with the team already for 17 years. He's been doing everything from testing, development, and management. He's been involved in successful shipment of MSVC compiler, starting from Visual C++ version 7, now to Visual Studio 2017. Privately, he's a huge sport fan, particularly basketball, and active cyclist. He's also, you can find him at Strava. He's also eager to share his experience and his results in cycling. What I was really happy to hear from Ulzii is that he learned about code dive from his fellow colleagues in Microsoft. Apparently, in some parts of Microsoft, this conference is already quite popular. So, straight from Redmond, Washington, the best person to give you 7 reasons to move your C++ code to Visual Studio 2017, Ulzii Luvsanbat.
Thank you for that great introduction. It feels good. This microphone is on, right? Okay. You all can hear me in the back? Okay. Hello, Dzień dobry. Nice to meet you all. Like he said, my name is Ulzii Luvsanbat. My full name is Bat-Ulzii Luvsanbat. I go by Ulzii. Today I'm here to talk about why should you use Visual Studio 2017. And there are 7, for some reason, there's 7 reasons why you should move your code. 7 is just an arbitrary number. There are many reasons. I picked 7 just to get you thinking. Like, why 7? Why, not 8 or many? Many is boring. But really, there are many reasons why you should be using VS Code in Visual Studio. And, in the hour or two list today, I would like to show you some slide decks as well as demos on C++ inside Visual Studio. Before I start, I'd like to extend my gratitude to Code Dive conference organizers for making it possible for us to participate in this great conference. I came 2 days ago. This is the first time Microsoft Visual Studio team is represented here. Like he said, I heard about this conference from my Polish co-workers a few months ago, and it was very C++ heavy when it started first, and it still is too. So we figured like this is a worthwhile conference to come to share our product and reach out to C++ users in this area. And to my satisfaction, I find that there are many excellent technical leaders and engineers here in this area. I'm blown away how many young C++ developers are in one place gathered. It's pretty amazing, actually. So thank you for the honor. My role at Microsoft is I'm a group engineering manager for the C++ language group. That group is responsible for the MSVC, the C++ compiler, specifically the front-end part, the part that's responsible for parsing, lexing, creating AST, APIs, standard conformance, diagnostics, so that part of the compiler, as well as the libraries, STL, CRT, ATL, MFC, C++ libraries that we ship, as well as VC package, package manager for C++ libraries, and just the overall packaging for the C++ tools. So that's what my team is responsible for. So any issues you find, any bugs in these areas, you can blame me, and I will make sure to relay that to the team. So before we start, I'd like to do a little bit of a celebration. I think a lot of you use Visual Studio, VS Code. I was handing out some stickers, and somebody said, he loves VS Code. I think you, the guy in a red shirt. So thank you for using Visual Studio. Thank you for being our customer. Believe it or not, Visual Studio and Visual C++ has been around for 25 years this year. So this year is the 25th anniversary for Visual C++. That's back in, 1993 when Visual Studio 1 started. I wasn't even born. That's a joke. Hey, by the way, if you laugh at my jokes, I'll give you T-shirts. Okay? I brought. Yeah, that was a good joke. Well, I mean, now everybody's laughing. I don't have enough shirts. I brought some shirts for the celebration for the 25th. This was the first Visualize Your Masterpiece. Was the first theme when Visual Studio came out first, and there was a commercial on TV, with this logo, with this pattern. So we have shirts. I have some shirts. I only brought enough that that I can carry. Turns out it's a long flight, from Seattle to here. So I may not have enough for everybody. But like I said, if you laugh at my jokes, even if they're not funny, you got a shirt. But if there's not enough, everybody can have one. You just have to be okay with sharing it with somebody else. Okay? So 25 years, and here's hoping we go for 25 more years in catering to the most hardcore C++ users in the world. So Visual Studio 2017 has been around since March 2017. The release of Visual Studio is kind of funky. We used to release versions, within 2 or 3 years in the old days. Now, I don't know if you noticed, we are releasing more rapidly. The major versions, Visual Studio versions, they still go out within a year and a half or 2 years. But within that, there are major updates. These are denoted as 15.1, 15.2. These are not, small Mickey Mouse updates where you have, little bug fixes and stuff, as we used to have before. These are real bona fide feature updates with, breaking features, with features that people, should move to or take dependency on, as well as bug fixes. So for Visual Studio 2017, there have been 9 updates, major updates, every 3 months. So every 3 months, we put out a new Visual Studio. This Visual Studio is a behemoth, you've used it, right? You've installed it, right? Some of the old ones takes hours to install. It is a huge, huge product. It can do a lot of things. For such a big product, we're able to rapidly ship user value add every 3 months is it's not an easy task. It's a big deal. So 15.9 is the last one for Visual Studio 2017 series. It is out sometime in November, probably the end of November. The last Preview 5 is out yesterday. So yesterday was the day that Preview 5 went out. So the mission of the C++ team at Microsoft can be explained in 4 folds. Simply put, we want to make the lives of the C++ developers in the world better by providing the tools at your fingertips when you need, wherever you need. That is the motto, right? And how do we do that? There's 4 simple ways that we kind of strategize to achieving this goal by participating in the C++ standards. I don't know if you know, this week, C++ standards by 6 monthly meeting. So it's like every 3 months there's a standards meeting. There's one happening right now in San Diego. We sent 10 developers from my organization. That's how heavily we invest in the C++ standards. As you know, the C++ is a global language. Microsoft does not own the language. Nobody owns the language, but we definitely contribute to its success and development. I can, a few examples that I can mention. The C++ modules, C++ code routines. These are some initiatives that were started from Microsoft engineers, and we not only did we submit the proposals, we get it through the standards procedures, as well as implemented it in Clang and in our compiler MSVC. We invest in the compiler. There are about 3 production-level C++ compilers in the world right now, people that heavily use. Most of you already use GCC, of course, Clang and LLVM, and MSVC. We have been investing in the MSVC compiler from 25 years ago. In the last few years, we have heavily invested in making the compiler more conformant to the standards, and more importantly, catching up with Clang and GCC with respect to being cross-platform and standards conformant. And I'll talk more about that. What we have in this regard and what we have achieved so far by improving Visual Studio IDE. Visual Studio has so many strong characteristics. One of the things is the integrated development environment, the Intellisense, the code understanding features. It's enabling you to write your code without being hindered by your environment or your ecosystem or your tools. It just gets out of your way and naturally exposes all the capabilities of the computer to your fingertips, right? I mean, that's kind of simply to describe what Visual Studio does. And, we are continuously improving in that. There's still a lot more ways to go, but we've done a lot of good improvements to improve the productivity of C++ users. And by continuing to enhance the C++ extension to Visual Studio Code. Visual Studio Code, as you know, is a lightweight, keyboard-centered, focused Visual. It's a form of Visual Studio, but it's a cross-platform. It has native Git and GitHub integration for source control. I think many of you already use VS Code. Can you raise your hand? If you use VS Code? Yeah, I kind of expected. It's very rapidly growing its popularity, and the C++ extension to VS Code has as much as all the bona fides, the code editing and browsing features that you would see inside the full Visual Studio build, as well as the debugging experience that you love, and it is cross-platform. Okay. So, Visual Studio. We make Visual Studio. I think the connotation for Visual Studio historically have been it's for Windows, right? It is for C++. The C++ language itself is cross-platform, but the Visual Studio trademark has been for Windows. In the last few releases, especially in Visual Studio 2017, we have tried to break out of that trademark. It is truly cross-platform. As I said, VS Code runs on multiple platforms. Visual Studio, even though it runs on Windows, actually there's a version that runs on Mac as well. Even though it runs on Windows, you can develop C++ code that targets multiple platforms. And when you do that, our job is to make sure that all the code understanding and this developer environment supporting tools and features are available to all of these scenarios, not just when you target Windows. So that is one of the main improvements that we are making in Visual Studio. And that includes, code editing and debugging, Intellisense, refactoring, conditional breakpoints, debug visualization. All of these features have always been available on Windows, but when you target different platforms, they just drop off, right? And we are bringing them back up to a parity. Also, in VS 2017, towards the end of the updates, we have natively integrated Google Test, Boost tests, Clang format. You can install Clang and LLVM and GCC, different compilers other than MSVC, and build your project targeting Linux and Mac platforms inside Visual Studio. These are unheard of. These are things we haven't done in any of the previous releases. So I have two demos today. One of them is, the first one is going to be targeting Linux. So let me come here. So I'll start off here in the command prompt. This computer stand is kind of flimsy, so it's difficult to type. So what I have here is a Hyper-V server running, and it's hosting in Ubuntu Linux 18.04. So let me just log into that. Okay. And dismiss this. So I get this ready. So before I go to Visual Studio, I'm in the command prompt, and I want to talk about VC package. When I say VC package, how many of you understand what that is or have used it? Well, good. That's good. That's good. 30%. VC package is a cross-platform C++ package manager from Microsoft that is open source. Notice I didn't say Windows. It is for Windows, but it's not only for Windows. So we've been working on this last 2.5 years. Its popularity and usage is rapidly growing, and it has. We have made a lot of improvements in integrating it to more and more developer scenarios inside VS Code and Visual Studio. So here, you can see the screen here, right? So if I type VC package search SFML, it's a simple, fast multimedia library from GitHub. It's an open source library. I have a simple program, an application Pong game simulator that I'm going to basically use for this scenario, which depends on SFML. And I'd like to use that to target Linux through Visual Studio. So that is what the demo is going to do. So before I start that, I run VC package search in SFML, and it gives me these 4 versions. What is this? It means there are 4 versions of SFML installed and available in VC package open source as an open source library. Why? Because VC package is rapidly growing. Today it has over or close to 1,000 different C++ libraries available, and 800 or so of those target Windows, and 400 something of those target Linux. If you think about it, up until VC package, we really didn't have any source level, package manager for C++. For Windows. So VC package is first of its kind for Windows, and using it is simple. It's as simple as apt-get on Linux and homebrew on Mac, right? It is source-based. You get the sources that's blessed by the VC package manager, and then it seamlessly integrates with the tool set Visual Studio compiler that's available on your computer, builds the library, and basically makes available all the libraries and binaries for you to use on the machine. So one of the most important commands for VC package is VC package install integrate. Whoops, sorry. I think I got this wrong. Integrate, install. So what's happening here is, in a way, this is one of the most powerful features of VC package. What it's doing here is it's making all the libraries that are downloaded or synced from VC package to this machine and built, and integrating the include libraries, include folders, search folders, lib folders, and the binary drops, making them all available to Visual Studio internally. So you don't have to set that up inside Visual Studio. It seamlessly integrates to VS in a way that when you create a new project inside Visual Studio, you do #include, automatically it'll search and it'll include header files from the VC package folder or downloaded folder. So that's inside Visual Studio. It also gives you a note here in case your C++ project is CMake based. This is where you want to. This is the environment you want to set inside the CMake file, a JSON file. Have it connect, point to where the VC package libraries are. So, this will become more important as we go through the demo. So, what I have here is I'm going to start the game here on the Linux box. So, as you can see, I have the Pong based on SFML already built on the Linux box, and I'm running it right now. How did I do that? How did I build this thing? This is the project on Windows on Visual Studio. As you can see, this is a folder view, not a solution explorer. This project is CMake-based project, and therefore all I did was I pointed this Visual Studio to the folder and said open it, and Visual Studio did the rest. It said, okay, I see a folder and I see a whole bunch of source files inside. Let me scan all of them and figure out what the project system is. If it was a Visual Studio solution or project file, normally you just click on that and everything will be loaded. Visual Studio knows what to do. All the features will be lit up in Visual Studio. That was always the case. When we have improved supporting cross-platform projects, this is one of the things I'm talking about. We support C++ projects that are CMake based. Nothing to do with Visual Studio, nothing to do with Windows. A CMake project that builds on Linux, maybe a C++ project that only builds on Linux, and that's where it started, and it's CMake based. If you have one of those, all you got to do is just load it, open, you go to Visual Studio, you do open, folder. You do that, and you point to the folder. The Visual Studio will interrogate all the files inside. It'll notice that it has a CMake list text file, config file. This is the universal CMake configuration file. It'll notice that it'll figure out, oh, this is a CMake-based file, and it'll create a JSON settings file that has some, boilerplate code. You don't have to mess with this, except in here, you just have to tell where the VC package CMake tools are, because CMake, you get CMake from VC package through Package Manager, and you install it. So earlier, I showed you that when we ran integrate, said, hey, yeah, if you have a CMake project, then use this to have it point to us, right? And this is where you would add that here. So I got this project. Notice I have full Intellisense. This is a CMake C++ project, but it's behaving and working just like a bona fide Visual Studio solution-based or project-based project. Okay, so I set a breakpoint here, and then what I'm going to do is I'm going to change the target to Linux debug, and then I'm going to debug the executable. So before I do that, I need to somehow connect this Visual Studio to the Linux that has the game and everything, so that when I build this project, Visual Studio will orchestrate copying the files, the executables, binaries, and libs to the Linux machine, and copying source files back to to Windows to orchestrate all this developer environment. You don't notice it, but it's all there. But how it's working behind the scenes is actually pretty amazing. So to show you what's exactly happening is, I'm going to go here and type connection manager. By the way, this little window here at the top here is a really good quick launch for VS. Remember I said VS is a behemoth. It is a behemoth. It is packed with features that I've never even used it, and I've been working on this for 17, 18 years. So finding what you need is a difficult task. That little window is awesome. So use that. You just type. It's a fuzzy search. So this is where you would add. You come here. Normally you wouldn't see this entry here, and then you click add, and then you basically say, okay, what's your host name, your Linux computer name, port, username, and a password. Done. It'll connect through SSH to the Linux box. After you have connected, you would see this. And here's one something I want to show you. Once you've connected, this when you do a build inside Visual Studio, obviously all the binaries will be ported or will be copied over to the Linux machine, right? But Visual Studio will also copy a bunch of sources and header files, all the necessary files to orchestrate this kind of deep IntelliSense and browsing experience inside VS back from Linux to Windows. And this is where you put it. As you can see here, I've got the home. This is basically the mirror image of what I have on the Linux box. Why do we need this? I'll show you why. Ready? So I got on the Linux box, I have the thing running, right? One of the feedbacks we got from the earlier releases, yeah, it's nice to debug native C++ applications on a Linux box from Windows-based Visual Studio, right? But there are many scenarios where on the Linux, you're not running an application, but instead you're running a service, right? It'd be nice to attach to a natively running C++ service on a Linux from this rich Windows environment, Visual Studio environment, and get all this debugging experience. We listened, and in the 15.9 release of Visual Studio, that's exactly what is supported. So I've got, let's assume this Pong game is a service running on the Linux, and then from the Visual Studio, from the Windows side, I'm going to attach to it. I'm going to attach to it because I've set up Visual Studio to connect to that machine already, and because of that, it knows that it can use this information becomes available in this window. So I do SSH connection target, and then there's a little search window here. Normally, it would have all the processes running right now on the machine. There's a search window here. I can type Pong, and here's the little Pong service running on the Linux machine. So I'm going to attach. This is native C++ code, so I'm going to use, notice here it says GDB. The Visual Studio debugger is now piping through GDB to actually do the debugging. And then it orchestrates the source level debugging, stepping, and experience through the header files that it copied back inside Visual Studio. So I do this. Now I'm connected. I'm attached to the native C++ service running on Linux from Visual Studio Windows. So I've got a breakpoint here in case I fail this game, right? So let me fail this game. Look at that. It just broke. Yeah? This is real-time debugging, breaking inside Visual Studio running on Windows from a natively running service, native C++ service running on Linux. This is the time to clap. So, as you can see, I am attached. The game stopped. This would be the service. And here, you get all the full debugging experience that you would get when you're running on Windows or building or debugging on Windows. So let me show you this thing here. So while I'm debugging, I'm going to right-click here and get position. Get position is one of the functions that comes from SMFL. SFML. Yeah. So I'm going to do a peak definition on this, and it's showing me this is what the definition looks like for get position. Now I'm going to come here and we say, oh, it comes from this transformable HPP file. Look at this. Where can you see the little tooltip? It's going to expire soon, but I keep pointing at it. Notice it's actually coming from that mirror file. It's actually coming from Linux. So this is the most important part. We're not simulating or cross-building this application to a Linux platform. Instead, Visual Studio is orchestrating a full build and debugging scenario that's happening on Linux from Visual Studio. And proof of that is this, right? When I step through this code, the Intellisense aspect of this is provided by the header files that are on the Linux machine. You know that's why you could trust the data during Intellisense that's provided to you. All right. So I've shown you attaching. I've shown you this. Okay. So and obviously all the features that normally available. Stepping in, all of this it works. So one more thing before I move on with the slides is I'm going to keep harping on this design time features, Intellisense and browsing features. Okay, imagine I change back to Windows. So I just changed it back to x86 debug. Right now, I changed the configuration to Windows. I didn't change anything in the sources. Intellisense is still there. And then I go to same function here, and I say, oh, give me the definition for this. Now, this header file better be coming from Windows, not the one from Linux, right? Look at that. See, I'm not lying. This is not a show, right? This is not an orchestrated thing. This is like a real back and forth development that's happening at a very high fidelity. So another thing I can show you is, let's say I call a function in this application that's only available on Windows. Sleep. It comes from Windows.h. So if I do that, because I'm targeting the Windows configuration, it's okay. Windows.h is available to me. I can build this thing and run it. It's all good. However, as I did that, I got this purple squiggle. Can you see the purple squiggle? Yeah? Well, you guys have good eyes. I can't see it here. Oh yeah, it's there. Okay, so there's a purple squiggle. What is purple squiggle? You've seen red squiggles, right? What's a red squiggle? It's an error, right? It's an Intellisense error that if you do a build, you're going to see it in the compiler. Like it's an early error. What is a purple squiggle? Purple squiggle is a new feature that's added. In case your project is a cross-platform project and has multiple targets, platforms that in its configuration, then our Intellisense actually behaves differently. It looks at your code saying, if I see code that will not work for the other platforms that you have in your configuration manager, then I'm going to let you know. It doesn't matter which configuration you're on, so that you don't have to. If you just do a full build, you don't have to experience it later on, down the line. Because some builds take hours and days, and it's the earlier you find out these things, the better. So here's an example. You see a purple squiggle down here. It says, "Oh hey, your Pong application for the Linux debug target, this sleep function is undefined." That is exactly what you need to know, right? Isn't that amazing? That's there you go. Yeah, you better keep clapping if you want a T-shirt. So to show you that I'm not lying, I keep showing you proof. If I did this, if I change the configuration to Linux, then those squiggles should turn into error, right? That means changing color from purple to red. That's exactly what happened. So yeah, these are real features available now in Visual Studio 2017 in the latest update. You don't have to hop over to Linux machine to do your development. You can do all of it here inside Visual Studio, and the Visual Studio will orchestrate and do everything for you the way you would do it on the Linux machine or the Mac machine. So that is the key takeaway from this demo. Okay. All right. So that's good. Oh, I'm glad this worked, because last few days, the Linux machine changed its IP configuration, and I had to come back here, debug it, and change it in all the right places. Turns out there's no network here, internet here, and somehow the demo was dependent on internet. There was a lot of things, so I was kind of sweating until this morning. But that's good. So I just shown you the open folder experience. Time. Okay, I gotta keep moving. Basically, it's exactly as I shown you, as advertised. You got C++ code. You don't know what the build system is, project system is. You just point Visual Studio at it, see what happens. Okay, it will figure it out for you. That's the crude way to put it. It's easy to get started, as you saw. A lot of the Intellisense features, they light up. Refactoring tools, squiggles, all kinds of features available on Windows, they light up as well. Okay, CMake support. It's based on open folder experience, as you saw. When you open a CMake project, Visual Studio will interrogate its CMake files, CMake settings.txt file, and it'll figure out what the build targets are, and it'll enable browsing and Intellisense information. And with CMake projects, you can target Windows, Linux, MinGW, Cygwin. You don't have to hop to different targets. You can just make Visual Studio your home base to do this development. Linux targeting. I was using Ubuntu 18.4 or whatever, but any Linux distro is supported. Remote VMs, IoT, and anything running small devices that are running Android or a version of Linux, all Linux distros. To make here it says cross-compile, right? We also have cross-compile support using Clang, but what I've shown you is the real built-in experience that's happening on Linux. So it's different from the cross-compilation. So just want to make sure that that's... So VC package, as I mentioned, it is one of the first source-level C++ package manager that's sponsored by Microsoft, but it's open source. Over 1,000 libraries available, 400 of those target Linux, and it's rapidly growing. we have so many PRs submitted right now. We can't even keep up with that. So we're working on leveraging the community to work through all these PRs and engage the community on development and growth of this. So all these features that I'm mentioning to you, I'm obligated to say to you that it's free. Visual Studio is free. Visual Studio Professional version is free to individuals or small companies, small businesses that do development on C++. You have all this for free. You have to be huge, big enterprise, to sign up for licensing. But otherwise, it's free. So that's good, huh? Isn't that a good thing? It's free. Free is good. Yeah. All right. So let me talk about the compiler itself, MSVC, and the libraries. I don't know if you noticed in the last, let's say, 3 years or so, MSVC, the C++ compiler for Visual Studio on Windows, we have been pushing hard in trying to catch up to the C++ standards. Did you all notice that? Was it noticeable? Good. Thank you. Thank you for noticing, because that's a lot of work. There was a lot of work to do. We were so behind in the standards with respect to the template-based, advanced template-based features. Clang was just like rapidly catching up and then just totally got ahead of us. And GCC, always been very conformant, good compiler. But I'm happy to say that with Visual Studio 2017, specifically with 15.7 update this year, July, we finally caught up. We are C++ 11, 14, and 17 conformant. And we can say that with a straight face. Yeah? I cannot do justice in saying how much work it was. Let me just tell you what it means. Basically, we have rewritten the parser underneath. So when you run the MSVC compiler today, it is running the old Lex and Yak based compiler. It's still running that, but right next to it, we are running a new recursive descent parser to build up the parse tree and the ASD. That is the only way we can support expressions finite, two-phase name lookup, C++ 14 and 17 advanced template features, concepts in 20. Like all of those can be supported. Otherwise, if you don't have a parse tree in ASD, there's nothing you can do. So our team has been working really hard in bringing up a complete new compiler underneath. I'm quickly running out of time. I must be speaking a lot. So let me just quickly run through this. So 2017 is standard conformant. What does this mean? Can we build Boost Hana? There are so many open source C++ libraries that the Visual Studio MSVC does not support. Never was able to build. Right? You know those. Two examples of those are Boost Hana and Range V3. Right? Clang and GCC, they just work. Our compiler has never been able to compile. I'm happy to say that starting 15.8 in Visual Studio 2017, it's already shipped. Boost Hana compiles clean. You don't have to download the Microsoft specific version. You can go straight to the master repo of Hana to get the latest one, and you use that against Visual Studio compiler. It'll just work. It'll just work. And guess what? Range V3 will also work with 15.9. Yeah, it heavily depends. Now, turns out it heavily depends on the alias template, Range V3. And an alias template is one of those features that really depends on having a full parse tree and ASD, which we finally was able to push that through. So with 15.9, and there's a VC blog just went public yesterday explaining all this. If you're active on Reddit or Twitter, Reddit r/CPP, there's a link there that you can read about it. Permissive minus. This is a new switch in the compiler we've introduced in VS 2017. It basically means strict mode, right? Change the compiler to be more strict and conforming to the standards. So under the permissive minus switch, you can build range v3 in 15.9. So it's more conforming. It is fully integrated to VS. You can change it in the project properties. It's not on by default because it is breaking, meaning there's over 30 years of legacy C++ code that have been building with Visual Studio, right? And these are customers like, I don't want to touch my code. Like this legacy C++ code, it just works, right? Who knows what's there? Like somebody 20 years ago wrote it and it just works. Nobody touch this, And then if we release a Visual Studio that, where permissive minus switch is on by default, our compiler is gonna like, oh hey man, you got like so many illegal C++ code in here. Like it should not have been compiling, right? And the owners of those are like, I don't care, right? Make this thing work. There's nobody that we have that knows about this code, so it just needs to keep working. We have so many that kind of customers, and we have to make sure that they continue to evolve with us as we release new Visual Studio versions. For that reason, we cannot make it the default, but you can turn it on. We also have standard version switches, C++ STD 17, 14 and 17. 14 is on by default. Soon we will make the 17 on by default. Latest is basically the latest features that are being worked on. Right now we're working on C++ 20 features. This is very early on. One of the main features in 20 is concepts, C++ concepts. Our compiler is going to be one of the first ones to support that, along with GCC, of course. But we're working on that right now. So, upgrading, when we release new Visual Studio versions, Visual C++ versions, we can't look through just the compiler lens. We have to look at it through the product lens. And the most important thing for us is to continue to make it easy to upgrade, pain-free upgrade to our customers. And that is still our number one focus when we release new Visual Studios. Okay, so every time we release, we build these open source libraries from their trunk, from the root. So, like some of these libraries, maybe you already use it for your project, but these are the open source GitHub projects that we get live sources, and we build them and make sure they build clean before we release the new compiler. This is an exercise we didn't used to do before. We made it part of our release gauge for Visual Studio 2017. As we do that, we contribute codes back to these open source projects. All these blue ones here, we have made changes in them because our compiler has found bugs in those sources. And their owners were very gracious enough to accept our PRs and make these changes. So we're trying to become part of the community. Okay, so I'm gonna do a quick demo of code analysis as well as some of the productivity features in the IDE. Okay, so I totally screwed up the timing. I only have 10 minutes. So Visual Studio Inner Loop is basically what have we done to enable you or make it easy for you to do your day-to-day development, right? And that means your inner loop. You're loading your project for the first time. You work on a big solution with all your coworkers, and loading the solution is cost. How long does it take? Cold boot, warm boot. When you do a small change inside a CPP file, and when you rebuild, does it build the world, or does it just build your code, your changes? All of these things are important day-to-day inner loop activities that we must improve on in order to make your lives effective. So in that loop, we've made ton of improvements. Solution load is with 2017. You could see. I don't have to call out numbers here, but you can see that every update we are pushing the limit to closer to 0. Memory usage, again, with every release, it's getting better and better. The reason why is we have identified that this is an important area we need to invest in, and we're going to continue investing in going forward in these areas. So, real quick, let me go to. So here's a project. This is a pretty big project. OpenTTD, some train demo thing. I don't know what it stands for. So all right, so here, look what I have here. I've got a green squiggle now. So we've had red squiggles and purple squiggles. Now I got a green squiggle. What's a green squiggle? Green squiggle is a squiggle that comes from code analysis. The static analysis feature in Visual Studio for C++, it's been there before. It's always been there. But one caveat is you needed to do a full build of your solution in order to get the static analysis report. That usually takes a long time. And you don't want to be doing that all the time because your solution could take forever to run. Build. Now, in VS 2017, in the latest updates, we have provided. Notice I didn't do any build. I have not done any build. If I do a build, this will take minutes. So I don't want to do a build. As soon as I open the thing, I got a squiggle here from the static analysis compiler. So we now do a background parsing of your code with an eye towards finding semantic problems. So in here, yeah, good. Thank you for recognizing. This is a big deal. You can run this thing per file, per translation unit. You don't have to do you don't have to go out of your way to do a full build just to get the static analysis. So what is this saying? It's saying that this index here is out of range. So somehow this good num here is 64, but goods here is expecting it to be 32. So that's what's happening. Okay, what is this thing here? So let me go to definition. It's a macro. Goods num is 64, and there's a little light bulb here. What is this? What happens if I click on this? Oh, look at that. Convert macro to a const expr. Yeah? Yeah? What is this? So this is a new feature. Macros are, they're not good, right? They're difficult to, they're difficult to debug. They stick around. It makes code not readable, right? Now we're going to help you change these macros over time. There's no one single button you can click and fix it all, right? But you can do it on demand. You can do it case by case. Here it says, hey, here's a macro, and you can change it to a const expr. And this is what it would change it to. Const expr auto goods num 64. Huh? Why not? It's much better. Then it's C++, it's semantic. Compiler will understand it, and it's a better way to go. Now, I've got a function macro. That was just a simple macro that's resolved to a integer. Now I've got a function macro. This is fairly complicated macro, right? If I click on this, oh, look at that. We still give you an option to convert it to macro. Let's see what it's trying to do. See? Template. That to me is impressive, right? The first one was easy. It's a const expert. You could do that, right? You could just do find all, and do a simple change. That's semantic. There's some thinking going on. Somebody's thinking, right? Not me. I'm one of the developers who worked on this. Yeah, it's awesome. All right, so let's debug. Okay, I'm gonna do F10. Okay. So when I do F10, it starts from the beginning. I'm gonna do F11. Let's see, F11. Actually, let me see. Okay, so I'm right here. So I'm going to do F11 right now. Oh, it just took me to STL code, right? Here's a feature that we shipped right now in 2017. It's called Just My Code. Many of you have asked, like, when I'm debugging and stepping through, I don't care about the library's code, right? I just download a bunch of libraries. My code depends on thousands of libraries. I don't want to be stepping through all that. Like, I just want to step through my code, right? We have heard you, and now that feature is available. And it's on by default. I turned it off to accentuate my my demo. But here's... So right there. Enable just my code. By the way, this is on by default, so you shouldn't have to do this. But when you do this, and then I'm going to do F10 again. Okay? I'm debugging again. Now I'm going to do F10, F10, F10. I'm pressing F10. Okay, so this is where it stepped into any off, right? Standard. Now I'm going to do F11. Actually, you know what? F11. See? That's F11. I'm going to do F11. So, this... you might be thinking, you must have rigged something just to work it for STL headers. No. Just trust me, no. So this will work for any libraries that you downloaded. And when you step through, it'll work. Okay. So since I'm running out of time, I'm going to move on to show you one more feature that I think is pretty cool. Is inside template functions. If I hover over, let's say TA, right? It's auto, it's unknown, right? Or ST. Now we have a new feature where you click on the template parameter and you say, okay, there's a class called station. Use station to instantiate this template, right? Once I do that, what it's doing is the Intellisense is now simulating this template function with the type station and providing me Intellisense data based on that. So, look at that. Yeah? That's a big deal. Trust me, that is a big deal. So with this, what I can do is, see, ST is a template parameter, right? Inside a template parameter, when you do this, we provided nothing. Nobody can provide anything, right? Not just us, because that information is template. It's generic. You're not supposed to be able to, right? But with this feature, you can do stuff like this. You can. It turns out, when you have a template class and template things, most of the time it's instantiated with one or two types, right? Even though it's template, and you could use those to debug your code. Okay, so I'm running out of time. I have one last thing to show, and then I'm done. Okay. Sorry, host. Here. So there's one feature that it's pretty cool. Is multi-caret editing. So here's I got a using std namespace. Let's say I don't want to use this. Okay. If I do that, then I can do Control Alt, hold it down, and then I press here, and then I'm gonna press here, press here, press here, press here, press here, and then I type std : Huh? Yeah, you like that? It's good, right? Yeah. I missed a couple of. I assume I pressed all in the right places. Yeah, this is called multi-caret editing. There's actually more features. I don't have time to show, but there are more features that I could demonstrate in Visual Studio. Yeah. So since I'm out of time right now, let me just quickly jump back to the slides. Visual Studio 2019 is coming. We're not going to change our focus drastically. We're going to keep improving in the areas that we have been investing in the last 2017. Keep reporting your bugs through developer community, because we do listen and we do fix bugs. We respond as much as possible in developer communities. That is the only place where you want to open bugs for us. There's no other place. This is the only channel. Okay. So with that, thank you.